NEC Rule 376.25 addresses conductor fill in wireways. Section A dictates that for 4 to 20 conductors, the fill shall not exceed 40% of the interior cross-sectional area of the wireway. For over 20 conductors, the fill shall not exceed 30% of the interior cross-sectional area of the wireway. Section B clarifies that if the sum of the cross-sectional areas of all conductors exceeds 30% of the interior cross-sectional area of the wireway, the free space shall include the area of the space between the conductors and the perimeter of the wireway. Conductors passing through wireways on the shortest straight path without bend shall be counted at only one point where they enter or leave the wireway. Section C specifies that the area of the space between conductors and the perimeter of the wireway shall not be considered as free space for conductor fill calculations. Let's consider an example scenario. A wireway has a cross-sectional area of 144 square inches, that's 12 inches by 12 inches. There are approximately 63/4-inch conduits, each carrying 3 conductors for a total of approximately 180 conductors. Based on the number of conductors, the maximum allowable fill is 30% of 144 square inches, which is 43.2 square inches. The conductors in the wireway passing through on the shortest straight path without bends will only be counted at the point where they enter or leave. Considering this scenario, there are approximately 180 conductors with a total cross-sectional area that could potentially exceed the allowable fill of 43.2 square inches. Firstly, determine the actual cross-sectional area of all conductors. This will involve calculating the area for each individual conductor and summing them up. Secondly, check if the area exceeds 30% of the wireway cross-section. If it does, you may need to use a larger wireway or install fewer conductors. Consider the free space between conductors and the perimeter. This space cannot be used for conductor fill calculations. To determine the cross-sectional area of a conductor, you'll typically refer to NEC Chapter 9, Table 5 or Table 5A, which provides dimensions and cross-sectional areas of different types of conductors. For example, if you're using THHN conductors, you'll find the cross-sectional area listed for each wire gauge. Let's say you're using 12 American wire gauge THHN conductors. According to NEC Chapter 9, Table 5, the cross-sectional area of a 12 American wire gauge THHN conductor is 0.133 square inches. If you have 180 of these conductors, the total cross-sectional area would be 180 multiplied by 0.133 square inches, which equals 2.394 square inches. Now, compare this to the maximum allowable fill of 43.2 square inches. In this case, 2.394 square inches is significantly less than 43.2 square inches, so you would be well within the allowable fill. However, if you were using larger conductors, like 4/0 American wire gauge THHN, the cross-sectional area is 0.3224 square inches according to NEC Chapter 9, Table 5. In this case, 180 multiplied by 0.3224 square inches equals 58.32 square inches. This exceeds the maximum allowable fill of 43.2 square inches, so you would need to use a larger wireway or reduce the number of conductors. Remember to always consult the latest edition of the NEC and local codes for the most accurate and up-to-date information. It is also important to consider directing factors for conductors and wireways, as outlined in NEC Article 310.15. These directing factors may require you to use larger conductors than initially calculated to ensure the ampacity of the conductors is sufficient for the intended load. The NEC provides specific guidelines for directing conductors based on the number of current carrying conductors in a raceway or cable. In a wireway, if the number of current carrying conductors exceeds 30, you may need to apply directing factors. For example, if you have 40 current carrying conductors in a wireway, you may need to direct the ampacity of each conductor to 80% of its normal ampacity, as specified in NEC Table 310.15 cone. This means that if a 12 American wire gauge THHN conductor has an ampacity of 30 amps, you would need to direct it to 24 amps. To account for this dating, you may need to increase the size of the conductors to ensure they can carry the required load. In addition to conductor fill and dating, you also need to consider the bending radius of conductors in a wireway. NEC 312.25 requires that conductors be bent so that the insulation is not damaged. The minimum bending radius for conductors depends on the size and type of conductor, as well as the type of insulation. For example, NEC Table 312.6 provides minimum bending radii for conductors 600 volts or less. For 12 American wire gauge to 2 American wire gauge conductors, the minimum bending radius is 5 times the diameter of the conductor. For larger conductors, the minimum bending radius may be greater. It's also important to consider the support requirements for wireways. NEC 376.25 specifies the requirements for supporting wireways. Wireways must be supported at intervals not exceeding 5 feet unless otherwise approved. The supports must be designed to adequately support the weight of the wireway and the conductors it contains. Wireways must also be securely fastened to the supporting structure. When installing wireways, it's important to ensure that all connections are properly made and that all hardware is securely tightened. Loose connections can cause overheating and potential fire hazards. All wireway covers must be securely fastened to prevent accidental contact with energized conductors. Wireways must also be properly grounded in accordance with NEC Article 250. Grounding ensures that the wireway is at the same potential as the earth, which helps to prevent electric shock hazards. The grounding conductor must be sized in accordance with NEC Table 250.122, based on the size of the overcurrent protective device protecting the conductors in the wireway. When installing conductors in a wireway, it's important to avoid damaging the insulation. Sharp edges or rough surfaces can nick or cut the insulation, which can lead to short circuits or ground faults. Use proper pulling techniques and lubricants to minimize the risk of damage. When pulling conductors through a wireway, avoid pulling too many conductors at once. Overfilling the wireway can make it difficult to properly space the conductors and can increase the risk of insulation damage. It's also important to avoid twisting or kinking the conductors during installation. Twisted or kinked conductors can be difficult to terminate properly and can create stress points that can lead to installation failure. After installing the conductors, carefully inspect the wireway to ensure that all conductors are properly supported and that there are no sharp edges or other hazards that could damage the insulation. Use cable ties or other approved methods to secure the conductors in place. It is recommended to consult with a qualified electrician or engineer to ensure compliance with the NEC and proper installation of the wireway. Remember that electrical work can be dangerous, and it's important to take all necessary safety precautions. Always energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you're not comfortable working with electricity, hire a qualified electrician to do the job. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It's important to familiarize yourself with the NEC and to stay up to date on the latest changes and revisions. The NEC is updated every 3 years, so it's important to make sure you're using the most current edition. Many jurisdictions also have local electrical codes that may be more stringent than the NEC. It's important to check with your local building department to find out what electrical codes are in effect in your area. Understanding and adhering to the NEC and local electrical codes is essential for ensuring the safety of electrical installations. By following these guidelines, you can help to prevent electrical fires, shocks, and other hazards. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or engineer for specific recommendations and to ensure compliance with all applicable codes and regulations. In addition to the points already mentioned, it is also crucial to consider the ambient temperature when calculating conductor ampacity in wireways. NEC Table 310.15 BOEM provides correction factors for ampacity based on ambient temperature. If the ambient temperature is higher than 30 degrees Celsius, which is 86 degrees Fahrenheit, you will need to apply a correction factor to reduce the conductor ampacity. For example, if the ambient temperature is 40 degrees Celsius, which is 104 degrees Fahrenheit, and you are using a THHN conductor, you would need to multiply the conductor ampacity by 0.82, according to NEC table 310.15 bone. This means that if a 12 American wire gauge THHN conductor has an ampacity of 30 amps, you would need to derate it to 24.6 amps. Similarly, if the ambient temperature is lower than 30 degrees Celsius, you may be able to increase the conductor ampacity. However, it is generally not recommended to increase conductor ampacity unless specifically permitted by the NEC or local codes. It is also important to consider the voltage drop in conductors and wireways. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC 210.19 EON FPN number 1 recommends that the voltage drop on branch circuits should not exceed 3% to the furthest outlet for power, heating, and lighting loads, or 5% total for feeders and branch circuits combined. To calculate voltage drop, you can use the following formula: voltage drop equals 2 multiplied by K multiplied by I multiplied by D divided by circular mils, where K is the direct current constant, which is typically 12.9 ohms for copper conductors and 21.2 ohms for aluminum conductors. I is the current in amps, D is the one-way distance in feet, and circular mils is the cross-sectional area of the conductor in circular mils. To reduce voltage drop, you can use larger conductors, reduce the length of the conductors, or increase the voltage at the source. It is also important to properly terminate conductors in wireways. Use appropriate connectors and tools to ensure that the connections are tight and secure. Loose connections can cause overheating and potential fire hazards. When terminating conductors, follow the manufacturer's instructions for the specific connectors being used. Use the correct torque settings to ensure that the connections are properly tightened. Over-tightening or under-tightening can damage the connectors or conductors. It is also important to label conductors and wireways to identify their purpose. Use wire markers or other approved labeling methods to clearly identify each conductor. Labeling conductors can make it easier to troubleshoot problems and perform maintenance. When labeling conductors, use durable labels that will not fade or peel over time. The labels should be resistant to moisture, chemicals, and abrasion. It is also important to keep wireways clean and free of debris. Dust, dirt, and other contaminants can accumulate in wireways and can reduce the effectiveness of the installation. Clean wireways periodically using a vacuum cleaner or other approved cleaning methods. Avoid using water or other liquids to clean wireways, as this can create a shock hazard. It is also important to inspect wireways regularly for damage. Look for signs of corrosion, cracks, or other damage. If you find any damage, repair or replace the wireway as needed. Damaged wireways can be a safety hazard and can compromise the integrity of the electrical system. When working with wireways, it is important to be aware of the potential hazards. Wireways can contain energized conductors, so it is important to take all necessary safety precautions. Always to energize the circuit before working on any wireway. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with wireways, hire a qualified electrician to do the job. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or engineer for specific recommendations and to ensure compliance with all applicable codes and regulations.